Okay, good morning. So let's look at something small in our lessons concerning data science now. So let me share my screen. Okay, anyway, so there's something important that we have to tackle over here concerning social network analysis. In fact, whenever we create a social network like WhatsApp or Facebook, mostly we find some kind of relationships between the nodes or the kind of entities that are involved in such a social network. So if I take, for example, WhatsApp, you see that within a WhatsApp page, though we are all collaborating on the page to discuss certain things, at the background, you can see that some people too can be communicating among themselves at the background. That is what I mean. Example, if I have a data science class page, it is possible that the student in the A class, you see, the data science group may consist of all of you. Let me say C, D, and E. Actually, specifically, these are the classes that I'm taking. But let's say after creating such a group, you can clearly see that though we are all on the same page, some people in class A will be communicating among themselves. It tells you that when we bring a particular algorithm to study this kind of big network of data science, it should be able to find out that people in A are actually connected in a particular manner. And it should also be able to know that people in maybe E or D are also connected in a particular way. So this is what we call social network analysis. So within the big network, we have certain clusters that are created within. And these clusters, we call them communities. So let's continue. Social network analysis is the study of relationship. Let me try this thing again and see whether it will help me today. Okay, I'm trying to work on my pointer. Yeah, we say that it's a relationship and interaction between entities. And these entities are just the nodes, such as what? People, organizations, and what? Systems. So these are the things that we are connecting, but within it, we call them, these kind of things that we are connecting, we call them what? Nodes. But we are going to find a relationship between them. These entities as connected are what? Are connected by what? Edges. So remember I told you that computers or web pages are normally the nodes or the entities, and what is linking them are called what? Edges, when we brings it into what? Graph theory. Fine. So these relationships are such relationships are like what? Friendships. It creates friendships. When we come together, you can be able to see that there are some clusters of friendship or communities that are what? Being created among these kind of what? Nodes. Now, let's look at an example. The social network analysis is a way of what? Studying who is connected to whom and how they interact. So definitely, as I've just created or as I've just shown you, immediately we have a big network. Within the network, you can see that others are also forming somewhat, some small networks within. If you take the whole of UNED page, all the lecturers are on it, but you can clearly see that computer science lecturers also communicate among themselves in a particular manner. IT lecturers also communicate among themselves in a particular manner. So this system comes in the algorithm that we are going to study, specifically the Girvan-Newman algorithm, comes in there to look for these kind of what? Communities that are created or clusters that are always created within a big network. So example, we can have a WhatsApp as I've stated. When you have WhatsApp, The nodes are the people. When we take WhatsApp page, the nodes are always the people, and the edges are the messages that we always use to communicate among the people. So the messages serve as what? The edges. It's just like when you are on a web page and you click on a link and it takes you to another web page, as we dealt with in the what? Page rank algorithm. But in here, we are talking of how they link together by looking at what the type of nodes that we have or the entities that we are dealing with. Now let's talk of Facebook. Facebook too, the nodes are the users of the Facebook, just like the WhatsApp. But then there are some friendships that are being created. These friendships are the what? Are the edges. So they are similar over here. Now let's look at this algorithm. The Girvan-Newman what? Algorithm. When we bring in this kind of what algorithm, it's a community detection what method or algorithm using social network to identify these clusters. We only bring this algorithm in to come and look for these communities or these clusters of what? Closely connected nodes. So it will look at it and see that no, this person and this person and this person, they are connected in a particular way. Though we are all in a big network, they are what? Connected in a particular way. So by the time you realize, you see that they are all in the same what? Department or in the same class. That is it. The algorithm finds groups in a network by removing connections that link different groups. You see, I have a big group or I have a big network, but before you realize this person, this person, this person, and this person, they might be connecting in some way. And you see that this person too, this person too, this person too, and this person are also connected in some way. But there is something we normally realize. How can this Girvan-Newman algorithm detect the what, the class, or achieve that at the end of the day, within the whole what big group, we are only having two communities? Assuming I'm putting together class C and class D on my web page or on my what, not a web page, on my WhatsApp page. At the end of the day, the Girvan-Newman algorithm will know that these people are linked in some way. These people too are linked in some way. But not only that, it's possible that the class rep in this C class is also having some link with this class rep. It is also possible that there is a what? A particular guy over here who is also a church member of maybe somebody also here. So that link too still exists. But at the end of the day, we should be able to find out these links that are linking big networks or big communities. Then we remove them. If you don't find them and remove them, you will not be able to know that within the big network, you are having two separate classes. It's simple. So we look for these bridges, these links that are linking these two. We find them, then we break them. So you realize that within the big network, these people are having some kind of communication among themselves. These people too are having some communication among themselves, but not that alone. There is another bridge that also what happens between people in this bridge, in this community, and people in this community too. If you're able to find them and break them out, then you have your two communities within the what? The whole network. It's simple. So the algorithm finds groups in a network by removing connections that link different what? Groups. So there's something we call edge betweenness centrality. We are going to do that. That is what you'll be calculating. Then you use that one to remove those kind of what? Edges. So what is an edge betweenness centrality? So edge betweenness centrality measures what? Is the number of shortest paths that pass through an edge. So at the end of the day, you'll see that before somebody from here will be able to link to somebody here, he passed through a particular shortest path here. Before somebody here will also be able to link here, he also have a particular shortest path here. So if you are able to find these shortest paths, these are what we call what? The edge betweenness centralities. So these are the what? The edges that you are going to remove. If you remove them, the whole thing will break apart. So if many shortest paths pass through an edge, that edge is very important. So it tells you that If these people want to link, this person and this person want to link and they pass here, this person too and this person want to link and they also pass through here. So you see that this link over here becomes very important. So they are the type of links that we are going to look for, because it is through there that we create a bridge between two different communities. If you're able to remove them, then at the end of the day, you'll be able to separate the whole thing into what? The various type of what? Clusters or groups. It's simple. So we are going to look at the 4 stages. Please chew this thing by heart. These 4 stages are very, very, very important. What do we do? The first thing that the algorithm will do is that it will compute edge betweenness centrality for what? For each edge. Because we have a lot of edges inside the network. An edge here, another edge here, another edge here. Every edge you have to calculate the what? The betweenness what? Centrality. So at the end of the day, you remove the edge with what? With the highest betweenness. So at the end of the day, some of them are not having a lot of people passing there to join. So those that are having, it's like if I talk of this kind of what edge here, if somebody from here want to talk to somebody here, he will come and pass there. If somebody from here want to also talk to somebody here, he will also come and pass there. So at the end of the day, you see that this edge becomes important because most of the nodes communicate to a lot of nodes at the other side through this kind of edge. So immediately you see that tells you that one becomes the highest. So if this one is having about 4, this one is having only 1, this one is having maybe 3, then you go and delete the one with the highest value, which is the one with the 4. So you take that one off. So the next thing is that you recalculate betweenness for what? For the remaining networks. After you've taken this one off, because this one was having 4, you saw that one was the highest. You take it off, no problem. Then you realize that another one too is also existing that way. Maybe it is also having 3. So that is the second highest. Then you look for that one too and cut that one too off. At the end of the day, you get another one too, which is also having only 2 people passing there. Then you cut that one too off. So you do that until all of them are finished. So after that, you see that you'll be able to you achieve the way of dividing these communities largely into into 2 equal halves. As simple as that, or into 3, or maybe into 5. So that's how it follows. You repeat the process until the network split into meaningful communities. As simple as that. So the algorithm keeps removing the most important connections until the network breaks into groups. As I said, you first of all calculate the betweenness centralities. Those ones with the bigger value, you'll be cutting them off. Those ones with the bigger value, you'll be cutting them off until the whole thing gets finished. So at the end of the day, you see that the whole thing will be will be divided into 2 equal halves, or maybe into 3 or 5. Depending on the number of clusters that exist between the big network. Simple. Now, what are some of the rules? What is the rule of social network analysis? If you want to do something like what is our aim? It detects hidden community structures. You see, in those kind of social net, that's what we use in tracking terrorists. We use that one to in tracking maybe anything that is fraudulent online. You see, if today your questions in data science leak through me as a lecturer, it is easy for me to be caught from where it started to leak. If by adventure I know a student and I shared the questions with the student on WhatsApp, simple, there's an algorithm for us to just run in the IT department. It can tell you where the question started, the time that it was shared, and where it reached at a particular point at a particular time. So within the entire network of you know, it will be able to tell you how and the communication between I and between me and that particular student. It will measure all those things and be able to tell you. So it is used to detect hidden community structures. It finds groups of closely connected nodes. So within the big network, there are groups that will be having some kind of connections. So it will be able to find that. Then number 2, it identifies important connections between groups. So if there's a big group here and there's another big group here, There is a particular link that is connecting these, and we call that link the what? The important what? Connection or an important edge. Why? Because when you calculate the what? The betweenness, the betweenness centrality of it, it becomes very high. Then it helps analyze networks. How does it analyze the network? It analyzes it for what? For social groups, collaboration networks, and communication what? Patterns, as I've told you. Anything that you do online, don't think you are hidden. So whatever that you share with a colleague, there are algorithms that we can run to see whatever that you have been doing there and how it even connects the two of you. Then we use it for what these social groups, we'll be able to know that within the big network, these people are connected in a particular way. This one too is connected in another way. As simple as that. So that is it for the social network analysis. Now, another important topic is machine learning, but this thing we've already covered it. What I'm going to do here is just a recap. But then please take things very serious. So let's define what is machine learning. It's a branch of what? Artificial intelligence that enables computers to learn. It helps computers to learn from data and make decisions without being explicitly programmed. So at the end of the day, you don't program the machine before it works. You don't tell it what it does. So let me tell you an example. If I have a house this way and I want to design an intrusion system, I'll put what is called a human sensor. So what I'll say is that electronically, whenever somebody comes closer to this electronic sensor here, the human sensor, there should be an alarm here that should bell for me to know that somebody has come to the house. This is a simple algorithm that I'll just write inside this kind of what? There should be a microcontroller here or a microprocessor here for me to do that, just do this program. So in here, I'll just use if statement. If statement within this kind of algorithm, I'll just say if maybe the value here is high, it tells you that somebody is there, then alarm should also be high. Else means nobody is there, then alarm should go low. As simple as that. So this is what we call traditional programming. If you do something like this to a computer, a software or a hardware entity, it means you are doing what is called traditional programming. And machine learning goes beyond this kind of what? Intuition, or it goes beyond this type of paradigm. So machine learning is when computers learn from examples instead of being told exactly what to do. So for machine learning, I'll not do that. I'll try and come and put the software there. Then I'll be doing something whilst it will be copying or it will be studying. So we call something teacher-learner association or teacher-learner paradigm. Or teacher-learner relationship. Let me put it that way. So whilst you are doing and the learner is what? Learning. At the end of the day, it will also try mimicking what you have been doing. It's just like when you give birth to a child and the child is growing. The child will be watching you. Whatever that you do, the child will try to copy. That's what we are trying to do with the computer. And that one is what we call machine learning instead of what? Traditional programming. So you say that you give the data to him. What is the meaning of data? This thing happens and this is what I did. This thing happened and this is what I did. So immediately the child sit there and be looking at these things. What happened and what did you do? There was a time a snake came to the house, you screamed. There was a time there was food there, you wash your hand before eating. There was a time when you finish eating, you wash the bowls and put it on. So all these things are the data, the past history that the child will be looking at. Even if you don't tell him and you even recorded it on a what? On a movie, the person will look at it and copy it exactly how you have been doing it. And he will also try to behave that way. So that's what we mean by what? Machine learning. This one, I'm just showing you an analogy. So the computer learns the what? The rule. He only learns what you have been doing or what it is being taught, but not just telling him that when you see this, do this. When you see this, do this. No. It is going to learn from what has already happened. I'll give you some intuitions and you understand. Now, example, when we talk of email spam detection, how computers see spam and what actions do they take? you can use that data to train a computer to become a machine learning model. You can also use student prediction performance. Sometimes certain things, a particular software or the institution looks at how a student is what is a student behavior and be able to tell the student's performance. These things too can be used to train a software or a hardware to become a machine learning model. Then you can use something called image recognition. You can send a model into the farm whilst it is watching the type of plant disease that we have, like what I'm having over here. You try to let the software see maybe this, then you say that, oh, this one is a brown spot disease. The machine sees that, you say that, oh, this is a leaf blast, this is a leaf skull, this is a narrow brown spot, and whatever. Immediately you are doing that and you are recording it down. Tomorrow, when the machine learning algorithm sees another disease without even a label, it should be able to tell because you have already trained it with what? Previous examples. And these previous examples or the past history is what we call data when we come to machine learning. Simple. Now let's look at the basic components of machine learning. Every machine learning agent must have these four entities. What do I mean? What these? If you spell things out, or if I say that, okay, when I see the name Amma here, then I'll say, oh, the person is a girl. When I see Juliet, oh, I'll say the person is a girl. When I see Kwame, the person is a boy. When I see Kofi, the person is a boy. It's not easy to memorize all these things in a lifetime. But I see human beings, we've been able to memorize it. Do you know why? There was a data somewhere that we were learning. When you were giving birth to, your mother didn't sit you down to tell you that when you see somebody called Kofi, the person is a boy. When you see somebody called Kwame, the person is a what? A boy or whatever. Nobody told you that. But because you are mingling with the society and you see people doing that, that is why you are also doing the same. What if Kofi is not supposed to be a boy? You see, you would have also made a mistake, but you are just copying what the community is doing. So that thing is what we call data. You should have data. So the information used for learning is what we call data. Now, what is a model? It's a mathematical functions used to what? To make the prediction. So you know what? When you go to a class for your first time and you meet in maybe IT class for your level 100, you saw one guy, you try to predict the person's name. Maybe this guy, the way I see him, his name will be maybe Eugene. But it turned out that later you saw that the guy that you were thinking he's called Eugene is not actually Eugene. It's rather something else. Maybe he's called Johnson. Fine. The kind of way that you want to formulate the name in your brain is what we call the mathematical model. Because it's a model that is helping you to predict. Because you look at the way the guy is, you look at the way he talks, you look at the way he dresses and whatever, and you try to give him a name in a way. But at the end of the day, he's not the one. So there is a parameter that you have to update. This parameter that is in your brain, you have to go back to your brain and tell him that, please save this name for me for this guy. He's no more called this, but he's rather called this. I don't know whether you are getting me. So that is what we call the parameter. The value the model adjusts to improve accuracy. Your mathematical function will look at certain things and tell you that this guy is called Eugene. But then it turned out that it was not correct. Sometimes it can even be correct. If even it is correct, you still go back there to tell what is in your memory that, please, the guy that I say he's Eugene, truly he's Eugene. So record it for me. So right from that day, you will never make a mistake in calling the person's name. Then finally, you have what is called the cost function. It measures how wrong the model is. So when you tried predicting, were you right or you were wrong? So that's what we call your cost function. So always the cost function will determine whether you are doing the right thing or you are doing the wrong way. So let me take it again. The data is what is there for you to learn from. The model is the mathematical intuition or the formula that you use to predict. Then 3, we have the parameter. The parameters are the things that you try to adjust so that you keep in memory that right now you'll never make a mistake again. It helps you to improve your accuracy in predicting. Then the final thing is the cost function. The cost function will always measure. You see, people are very good in memorizing. But then at the end of the day, is it true that by 1 week time you still remember this? So that's what we use a cost function to measure. So the cost function measures how wrong the model is performing or how accurate the model is performing. Now we have 3 types of machine learning. We have the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. For the sake of your midterm, I will not be worrying you with much intuitions over here. I will just brush on certain things. But after this, we will take off with our lessons. Okay, now let me give you an intuition. In software learning or machine learning, we have 3 ways. The first one is supervised. What's the meaning of supervised learning? Assuming you have these 3 kids, then you bring a maid to the house to take care of the kids. Definitely, you are going to tell her their names. Then you say that this my first boy name is called A. The second boy's name is called B. Madam, please, can you imagine or can you suggest or predict what this guy's name is? This is a task you are giving to this madam over here. You have told him the first 2, but you want him to guess the last one. A lot of people will say C. At the end of the day, if it turns out that it is C, it tells that the lady was creating something inside her mind. She used a mathematical function, which tells that if the first thing is A and the second thing is B, then the third thing will definitely be C. So it was a mathematical model that she was creating in the brain. At the end of the day, what is she learning? She's learning from data. These things that you have already told her is the data. But is it true? If it is true, then she will just keep it in her mind. That becomes the parameter. But then as she was doing it, what did you use to measure to know that she was true or she was wrong? That was the what? Our last value, that was the cost function. So this is what we call supervised learning. The learner is learning under a teacher because you are teaching him certain things, then you leave certain things for him to solve. Example, when I have 10 questions for you in your exam, I come to class, I solve maybe 8 of them. Then I give you 2 of them to solve on your own. That is what we call supervised learning because I teach you what to do. Then at the end of the day, I ask you a question from the others that I never taught you. So based on what you have already learned, you can tell the next one. You see, most of you have never been to maybe Middle East. But if I ask you to write something about Iraq, Iran, Israel, and whatever, you can write about 60% of what is happening over there. This is because you are being taught of certain things. Though you have not been there, you have been given some kind of what? Information. Now we go to the next one, which is unsupervised learning. Here, we don't tell the learner. The learner will just come into the society, just be looking at what is happening, then to adapt straight away, to never make a mistake. I don't think any boy or guy will come to class wearing a skirt. Why are you not wearing skirt to class? This is because the day that you were giving birth to, you started learning about how men dress. Nobody sat you down. Your parents never sat you down to teach you. But based on how you are mingling with the society, you'll be able to adapt to it. So a clear example over here is that assuming you come and trip this kind of yam for a market woman, you never label them according to their names or whatever, or their size or their quality. But it will surprise you that within the next 1 hour, before you come back, this lady has been able to group the yams into some kind of groups or some kind of categories, and they look very much alike. This is what we call unsupervised learning. That one, we don't label it. There's nothing like labeling, like I labeled these two boys. There's nothing like labeling. But the user will just, or the software or the algorithm will just look at it and be able to know. If you would like watching some type of movies, the computer will be recommending movies that look like that one to you whenever that you go online. So these are some of the things we use in what? Recommender systems. Then the last one, reinforcement learning. This one, you learn by reward. Reward, we have the positive reward and we have negative reward. The negative reward is always called penalty. Example, when a child is growing, the child will taste apple and the apple tastes good. She will label it as positive or reward, positive reward. But when she tastes something like paracetamol, she will know that it is bitter. Then she will label that one as a negative what? Reward. So the next day, she will not go to the paracetamol. She will rather go to the what? The sweet ones. So this is what we mean by what? Reinforcement learning. Over there, the user learn from mistakes or correct this thing that she has already done. So whatever the performance that has already happened, it will based on either the reward or the penalties to take the next step. So that is what we mean by what? Reinforcement learning. So this is just the analogy. So now when it comes to these kind of what? Machine learning too, always you try to do something, then you check, am I right? If you are not right, you correct yourself. Always you try to do something, am I right? If you are not right, you correct yourself. If you are right, you still keep it. So in there, we have a particular function that we use to always update ourselves. And this is what we call gradient descent. And what we are actually doing there is what we call optimization. Watch something. If you are trying to what? Memorize a passage. First of all, we've written maybe the Ghana National Anthem on a paper, assuming you have never read it before or you have never seen it before. First of all, you try to memorize it or you try to say it. Then you make mistakes. The madam will tell you that no, please, you have made a mistake. Recite again. Then you go and look at it to the end. Then you start reciting by closing your eyes again. Then you make another mistakes. The madam say, no, you are on the wrong path. Start again. Then you come and look at the right thing. Then you do again. So all these things that you are doing is what we call optimization. What are you doing? You are trying to work towards the right answer before you stop. So optimization is just a method of what? Trying to correct an error somewhere. So let's see. In optimization, the model makes prediction, or when we come to this machine learning optimization, the model will try to make prediction, but they are not perfect. Normally, the predictions that you do might not be perfect. So what do we do? So we need a way to reduce that kind of error that you are making. Now that we know machine learning models learn from data, the next question is how does the model improve itself? So there's a data, you learn from it, then you try to practice. Learn from it, then you try to practice. But how do you correct yourself? Use what is called gradient descent, which helps the model to reduce its error step by step. It is done step by step, as I told you. You try to recite, you make mistake, go and look at it again, come and recite, make mistake, go and look at it again until you make it better. So gradient descent is an optimization algorithm used to minimize the cost function. The cost function is telling you the error. So whilst you are bettering yourself, you are reducing the loss function or you are reducing the cost function in machine learning model by what? Iteratively updating the model parameters. Remember I said, you do it, if you get it right, you go and update the parameter in your brain. If you get it wrong, you go and update. So whilst you are updating the parameters, you will be improving. Oh, this guy, I thought he was called Eugene. No, he's rather called Kwame. Then you keep it. What about this guy too? I thought he was called Kwajo, but he's rather called Kofi. Okay, let me update myself. So you do that until perfectly. By the time you get to level 400, it's possible that you'll be able to memorize everybody's name in the class. As simple as that. So gradient descent is just a method for reducing error step by step in what? Machine learning algorithms. So this is just another analogy. It's just like when you are somewhere in the dark. We want you to get down here and come to the house. You are on the hilltop. What do? You try, if the place is dark, let's say you are not seeing anything. You try to be moving small, small. You don't always run fast. No, you move small, small. But if you move small and you see that it is rather going up, I don't think you go there again. You rather go to the direction that is actually descending. So I move one step, I saw that it's descending. Okay. I move another step, it's descending. Okay. You will do that step by step until you come to the lowest point that you're looking for. As simple as that. Imagine you are standing on a hill in the dark and want to reach the lowest point. You take small step downhill. Always you take a small step. You don't take much. But if you take much, it is possible you may be going in the opposite direction. How do you know you are going what? In the right direction? So eventually you reach the what? The bottom. So the way you are going downhill is what we call gradient descent. Step by step method of what? Achieving your goal by moving in what? Small, small steps at a time. So it helps to achieve the following. It reduces prediction error because you are moving step by step. It doesn't allow you to make large error. No, because you move small step, then you check. Move a little step, then you check. That one will protect you from making errors, and it makes the model to very, very accurate. As I said, if you want to memorize a passage, look at it, recite small and see, am I right? Okay. Look at it again, come and recite again. Am I okay? In that order. Simple. So we'll be looking at this kind of mathematical equation. It's very, very simple. Anytime I want to update something in my brain, let me see, that one is what? Maybe theta 1. What do I do? This is what I'm updating. Finally, I have to have this one. I have to take the old one, which is theta 0. This is what I was keeping. I was keeping that you are Kwajo. No, I have to subtract something from the Kwajo and let it become the what? The new one, which is Kwame. So I have learning rate multiplied by what? The differential of the error. The error is always given. So if I made an error of maybe theta 2, I'll just differentiate it and I bring it and multiply it by the what? The learning rate. Then I'll subtract from the old value. Then I'll have my new value. It's simple. So it's D of the error. Let me use E here instead of the J. But this is the what? The normal notation. Divide by what? D of what? The weight or the value that I've kept, the parameter. So let's see a simple example over here. What this? A person is trying to reduce his mistake in solving a problem. Let's look at how you do. The size of his mistake is given by theta raised to the power 2, or maybe x raised to the power 2. Don't get panicked because this is just simple mathematics. Calculate the mistake level. No, currently the mistake level is what? Is this. They will tell you his mistake at a point. Now, how do you update it? We are going to use this formula. So we say that to improve the person adjusts their mistake using a method where they move a small step in a direction. That reduces the error. The step size learning rate is thus. So all these are the questions that are given to me. So they are just giving me the question. They say that the error function is given by this, theta square or x square. Then they say that currently the error that they are making is this. And I want to find a way of reducing the error. Then they say that the learning rate is also this. If they make one improvement step, what will be their mistake level? Now, if you try to improve yourself, what will be the next improvement, or what will be the next mistake? So at the end of the day, what do we do? How do we differentiate x square? X square or theta square, when I differentiate d of the what? Theta square will give me 2 multiplied by theta. You all know that. So it's just like you are differentiating x squared. Differentiating x squared will give you 2x. As simple as that. So we are coming to put it in here in this formula. Let me check this my recording again. Okay, so that we'll be able to